Okay, I think we've given enough time. Let's just jump into it. So welcome. This is the LaRouche PAC Saturday night course. And this is the finale of Ben Deniston's kind of dive into the um, the failed dogmas, lies, and rumors of the Green New Deal, and a sense of what real economics, real questions of economic growth and development measure and emphasize. So I think it'll be fun to see what Ben develops tonight, having taken us out to the galaxy and back, looking at the questions of production, industry, energy production, and really just the overall absurdity, not just of the legislation, which is, as we know, is dictated by a grouping of people that intend to destroy the country. But also for people that are gullible or naive enough to believe in the underlying assumptions to really question and challenge what really is mankind and what really is economy. Now, just a few brief words before Ben jumps in tonight. For any of those people who still believe that somehow the environmentalist Green New Deal agenda program, the same agenda from the Davos billionaires called the Great Reset, the same as this dying Biden regime, which has been basically a neoliberal regime for the last 75 years. All of its failures have been encompassed in this last week or so. Now, as many of you know, the Afghanistan situation has been somewhat gut-wrenching this week. And as one of the fathers of the fallen soldier said, it was clearly, from a carpenter's perspective, his son was deployed into what was nothing less than a turkey shoot, basically rounding up something that can't fly, can't run, can't really get away. You're going to have loss of life. But that's this regime. And perhaps that's not better summed up over these last 50 plus years than in California, where Ben hails from, which used to be a major industrial and scientific powerhouse, but has become really almost facing a series of biblical plagues. In this case, it would be drug addiction and homelessness, direct outcomes of Ken Kesey's merry band of LSD hippies and the drug culture that's ensued. Many of the people on the streets, if not nearly all of them, have mental and drug addiction abuse issues, and we've left them to kind of suffer the plights of these horrible not shelters, but encampments. It's raging with fires all over the state. I think I counted at least 16. There's probably more. That's probably just the larger ones. Ravaging the state. Pat Ruckert has continued to follow these reports in depth. You have a major drought, loss of water, but that also is a loss of electricity. They're shutting down the one remaining nuclear power plant. They're having to buy coal-powered electricity or turn on the natural gas plants. The state is just an overall crisis, and there are plans from the state legislature for a full-scale vaccine mandate for all internal places in the state within the coming weeks. So basically what's been done to New York City, they want to do to all of California, taking what's left of small businesses, restaurants, and other small business operations and just entirely shutting them down. This is the failure of the last 75 years, both in policy, but also in culture, and perhaps even more so in ways of thinking. How do we think about our society? Even how do we think, as Ben has addressed in previous discussions, the questions of what is real science? This empiricism and reductionism have just utterly failed us. And so it's a time for a revival of an entirely new quality of thinking. This is what Lyndon LaRouche prescribed nearly 60 years ago, and certainly over 50 years of work beginning in the late 60s and early 70s to put forth a true revival of the United States and a representation of the true America. And I think what Ben's going to discuss tonight is that, in essence, and very much the antidote to the crisis we see not only raging in California, but across the country. Just as a quick word, for those of you who are in California, we have a major recall election. Get out and vote. Take your ballot to a place where you can drop it off in person. Who knows what they're going to be counting, whose ballots they're counting, and how many times they count it. But do everything you can, because there is a firestorm, not just in the mountains of the Sierras, but in the minds of many Californians who have a sense we can reject Newsom, we can overwhelm the vote fraud they intend, and we can send a very strong message to this globalist neoliberal order. So those are your marching orders for if you're in California. If you're not, we've got to do the same thing in every other state, whether it's the rhinos or Democrats in power. We've got to have a citizen army ready to bring to bear these ideas and these policies. So on that note, Ben, I'll hand it off to you and see what you've got for us tonight.
Thanks, Mike. Glad to be on again. So yeah, like Mike said, this is going to conclude our series on the Green New Deal and real economic policy. I think tonight we're going to get into a little bit more the relation between, because obviously we're talking about energy, we're talking about electricity, the energy sector, energy production, right? That's central to the whole Green New Deal discussion. So tonight, to conclude this series, we're going to get into the implications of energy and electricity for the economy more broadly, and more specifically what Lyndon LaRouche looked at as the relation between two conceptions that he really defined: energy flux density on the one side and the productive powers of labor on the other side. And if you really want to get into what these terms mean, you really got to look at them in the context of the economy as a whole, as a totality. So that's what we're going to get into tonight, and hopefully it'll give people a good sense of exactly how, I mean, I think we've broken down the Green New Deal pretty well already. I think people have a sense of it not just being a waste of money, but a real entropic, catastrophic program for the economy. So today, we're going to look more at, well, what would work? What do we want to do? What's the future going to be? Not just for providing electricity and energy, but for uplifting the energy flux density and the technologies and the productivity of the economy as a whole. Real progress, real advance, things that will drive upward the potential relative population density of the economy as a totality. So let's just jump right into it. My slides going there. So we're talking about the economic transformation or green destruction. What do we want? It's a choice before us right now. And as we've covered, I think every single week for the past, whatever it's been, 4 or 5 weeks or so now, the Biden proposal, the Biden collective, the apparatus that's, giving this guy these speeches to read and telling him what to do and running his policy. They're pushing this crazy initiative for zero CO2 emissions from electricity generation by 2035. It's one of the objectives that's being floated, and other countries and other states, California, are looking at similar initiatives. This isn't even referencing the whole issue of vehicles and getting to electric vehicles and all that. So there's a lot of other implications to it, but that's kind of one of the benchmark aspects of this Green New Deal. Shut down coal, shut down natural gas. Although nuclear is CO2 free, there's no support for that. There's a little bit of support in these bills, but like Mike said, they're shutting down nuclear power in California. A lot of the real proponents of the Green New Deal, they're not for nuclear. They're for wind and solar. Is the main contributions to so-called renewable energy. And as we looked at last week, this would be an insane policy. Here we have an estimate of taking us from where we're at today in terms of electricity generation. If we were to simply maintain the same level of electricity generation, but shut down oil and natural gas, coal and natural gas, replace that with wind and solar, basically, the material inputs, concrete, steel, cement, copper, electronics, plastics, silicon, what have you, all the physical inputs to build the solar panels, to build the windmills, are 10 to 15 times higher per unit of electricity compared to something like nuclear. So the amount of physical inputs we'd have to put in to build up all of this massive apparatus to capture this low energy flux density source, wind and solar, means a huge capital investment, a massive capital investment, vastly increasing the physical inputs required, the physical costs just to generate the same amount of electricity, right? So you're putting in more just to get the same, putting in more just to get the same. That's what we see depicted here in this graph. This is the Green New Deal. And we juxtaposed that last week to our program, where why don't we say, let's go the opposite way. Let's phase out wind and solar, get rid of wind and solar. Like we said last week, if your neighbor wants to have a solar panel on their roof, let them do it, whatever. You know, we're not like outlawing these things, but this government top-down mandates to massive subsidies and massive programs to really force the large-scale implementation of wind and solar, cut all that out, get rid of all that, and we'll see these systems collapse. They're not really economically viable on their own. They're incredibly costly. So phase out wind and solar by cutting out the subsidies and all that. And let's go for a program of vastly increasing the energy supply. Let's double electricity production. If we really want to address the crisis in the global supply chains for American production, for American workers, for American laborers, if we want to bring back industry to this country, if we want to become a productive part of the world economy again, not just this services economy, not just a massive importer, what Mr. LaRouche called the importer of last resort at a certain point. If we actually want to reverse those policies, we're going to have to increase our energy supply. And we'll get into this a little bit, because a major part of the lack of growth or even decline in the energy consumption and electricity consumption and production in our country is directly attributed to the deindustrialization policy. So if we want to have industry again, if we want to produce again and not be reliant on this globalist run crazy system, then we're going to need to do something like we're talking about here. So the proposal here is doubling electricity production or consumption in these terms over the next, by that same time period, 2035. Do that mostly with nuclear power, replacing existing wind and solar with nuclear, keeping coal and natural gas basically where they're at now, and expanding everything else with nuclear power. We can see that because nuclear power is so much higher energy flux density compared to wind and solar, the total capital inputs and physical goods inputs into the electricity sector to do this actually goes down a little bit. So this is the opposite. You're not, rather than putting in more and more and more just to get the same, we're putting in less to get more. This is a negentropic program, right? So this is our proposal for the economy. I think we've gone over these before, you know, just more evidence showing how anywhere you had large scale implementation of wind and solar, the prices go higher because of the reasons we talked about. So, but we want to focus on where we want to go. We ended the last week's discussion with this a little bit. Why LaRouche PAC is so focused on nuclear power, nuclear fission power, the existing nuclear power technologies, but also nuclear fusion, the next frontier beyond fission. And this is something that Mr. LaRouche studied extensively and wrote extensively about. This is something that I worked with him personally on in my work with his leading a scientific research team for a number of years. We did a lot of studying of the relation between the advance of economies and the advance of societies being intimately tied to and connected to stepwise increases in the energy density of the fuel sources driving society and the energy flux density of the application of those energy sources into the economy. So this is a typical type of chart that illustrates that, just shows you how the energy per weight of your fuel goes up as you move from very primitive forms of energy, primitive sources of energy like wood, to the next step of coal, to petroleum, to natural gas. You get this stepwise increase in the energy availability per weight of your fuel, and then you have this dramatic leap going from chemical fuels to the nuclear domain. And we see nuclear fission fuel, and then fusion beyond that, and then really exciting frontiers with the fascinating domain of just complete matter, antimatter reactions. So you can kind of get a sense of where we've been going historically and where we want to go into the future. So the future is fusion. And last week we gave a little bit of an overview of some of the technologies or fusion demonstration systems and experiments that are being developed both by large government funded programs, but also a lot of really exciting small private ventures, which I think we're definitely gonna have to keep an eye on and start covering more, because there seems to be a lot of really exciting work going on in various alternative approaches, and in many ways potentially better approaches than have been getting support through these large government programs, which have been progressing, but just very, very, very slowly because of a lack of support. So, but what we're going to get into tonight is not just fusion as a source of electricity to generate electricity, although that'll be a major part of what we want to do, but how that can be the basis of basically a new industrial revolution type shift for the economy, a new opening up of entire classes of modes of production, types of production, capabilities that for producing goods, processing raw materials, utilizing new raw materials, just an overall broad transformation in what is possible in the economy, and how effective and productive the economy can be as a function of these new technologies. The frontier end of this kind of shift is really symbolized by this fusion torch idea. If anybody's heard of this or is familiar with this, this is something that was designed, looked at in the 60s, proposed in the 60s. So when people were first looking at the development of fusion systems, fusion technologies, fusion power, some people said, well, you can use this for electricity. Sure, that's great. We can generate electricity. Obviously, electricity is a huge part of the economy. We're going to need to do that. That's excellent. But what if we could use these fusion plasmas directly to get new raw materials, to process raw materials more effectively? What if we could use the fusion plasma to basically input very low grade ores, stuff that right now is not really economically viable to process, and utilize the high energy flux density, high intensity of the fusion plasma to basically break the whatever you're putting in down to its constituent elements and its constituent isotopes even, and separate out pure resources out of whatever you put in. You know, people have looked at just your average pile of dirt you just find in the ground that has resources in it. You know, that has material in it that could be useful, right? That has iron, that has oxygen, that has other things that could be useful just in any material, any dirt you find in your backyard. But it's so unconcentrated, the concentrations are so low that it's not worth it with current technologies to try and extract those resources. And we go and find higher concentrations, richer deposits of resources, and obviously prioritize mining them there. But as we look into things like an advanced fusion economy, all of that could change. You know, we're not going to start mining dirt just in your backyard everywhere right away, obviously. But it will allow us to begin to, you know, even look at landfills as potentially, you know, places where we've been dumping trash, you know, as potential valuable deposits now, because we can go back and reprocess and separate out all of the constituent elements in those trash piles and separate out the actual valuable resources in there and reuse that, right? So this is kind of like the pinnacle representation of the technology we could be moving towards, the fusion torch. Although that'll take some time to get there. One thing Mr. LaRouche was working on with an organization he created called the Fusion Energy Foundation in the 1980s was to look at what intermediate steps of plasma technologies, fusion related technologies, high energy flux density technologies were closer on the horizon as we moved towards these kind of full scale fusion technology systems. And there's a very fascinating article, a series of articles that came out in Executive Intelligence Review magazine in the mid 80s, which discussed some of this. A couple of the articles I pulled these figures from are entitled Steel Production in an Age of Universal Machines, 1985. Plasma Reactors Will End Reliance on Foreign Materials, also 1985. A couple of fascinating articles kind of fleshing out and filling out the perspective that Mr. LaRouche outlining there at that time. And they highlighted just some particular examples of what could be done in the relative near term if we start moving in this direction. And they looked at a technology being developed called magnetic separation technology, where instead of fully breaking down and completely ionizing a raw material input you're putting into the system, you can do it to a certain degree, a lesser degree, but still utilize a partial ionization and a magnetic separation techniques that would allow you to produce steel, for example, at productivities potentially 60 times higher than the most advanced technologies available at the time with this magnetic separation technology. And these productivity measures are based on the output per worker directly employed in these steel production facilities. So if you compare the kind of steel production facilities that were available at the time, again, this was the mid 80s, I'm sure there's places where the technologies have advanced somewhat, but I don't think anything on the scale that we were looking at the time there, like a 60-fold increase in the productivity per worker as a function of these plasma technologies. This magnetic separation could be used for things like aluminum production also. They were forecasting potentially a 20-fold increase in productivity. Again, the amount of iron or aluminum produced per worker in the factory as utilizing these new plasma separation, magnetic separation technologies to separate the aluminum from the ores that it's found in when you find it in nature. A 20-fold increase in productivity as a function of that. Other ways for separating uranium, which obviously for nuclear fission fuel, laser isotope separation processes, potentially a 40-fold increase over existing technologies is what we were looking at the time. But to really get into the significance of these things, like I mentioned in the beginning, you really want to look at these increases in productivity, these increases in the productive powers of the labor force in the context of the economy as a whole, as a totality. And this is a key part of the science of physical economics as Mr. LaRouche developed it. The key is that you want to study the economy as he described here in his 1985 or 1984 economics textbook. You want to look at the physical economic input and output of the economy, considered as a functionally indivisible whole. So if we're trying to judge the benefits of the technologies we just looked at very briefly, or judge the comparison of the Green New Deal program of wind and solar versus a nuclear fission driver program for the energy sector for the economy. Your basis for assessing what's better, where should we be going, is really found in the science of physical economics, right? In one of the previous classes, we were talking about the Green New Deal. We talked about how much more material cost it would be to build all these crazy windmills and solar panels. And someone commented on the YouTube video and they said, well, isn't that good? It would create more jobs, right? And it all comes down to what your metric is, right? If your metric is just creating jobs, and that's the limit by which you're assessing the potential benefit of different policies and different technologies and different directions for the economy, then you might be led to believe the Green New Deal is a great program because that's going to be a lot of jobs. But the problem is when you look at those jobs, what they're producing as a component of the economy as a single system, as a self-bounded single system, that's when you can really assess the inherent danger and fallacy and idiocy of the Green New Deal, because you have more and more jobs, again, just going into producing the same electricity output to sustain society, right? So this idea of the economy considered as a functionally indivisible whole really has to become something that people understand, to educate our fellow citizens and to educate our elected officials on the kind of policies that we need. And this is going to become an increasingly important political fight throughout the country in the coming weeks and months. As this Biden administration collapses, we really need, and this whole Washington D.C. elite is shown to be the incompetent fools that they are. We need citizens to understand the real policies that are going to get our nation out of this crisis, that are going to deal with the inflation crisis. They're going to deal with the supply line crisis, that are going to deal with the problems, the cultural problems that have been created by a post-industrial society, right? This is what's going to be critical for that, understanding real economic science, real physical economics. So just to break down Mr. LaRouche's basic framework, as he said in the previous slide, you're looking at kind of an input-output relation. It's a physical process you're dealing with, right? To run society, right? For us to have this discussion here, we're utilizing our computers, right? We're utilizing our phones. We're utilizing the physical infrastructure that carries those signals, that gives us electricity, that carries those signals to data processing centers, what have you, right? Every day we travel, we go to work, we utilize our cars, we work in the office buildings we work in, right? Society runs on the physical goods that are produced by your productive labor, right? What keeps society going, what allows society to function, everything from the food you eat to, again, the vehicles you drive, to the house you live in, to the place you work, to the capital goods you utilize in your work, in your own productive process. All of that comes down to certain physical good inputs that are required to sustain the economy. So that's kind of your beginning point if you want to study that, if you really want to understand, well, what improves that process and what doesn't? What makes that process more productive? What allows our productive labor to produce better goods, to produce more goods, to produce higher quality goods, right? And what's the costs of those changes? And how do you actually assess what's a good policy and what's not a good policy? So you have, again, these physical goods that sustain society. If we want to understand Mr. LaRouche's science of physical economics, the first step is to break down, well, where are those final goods going? Where are they going in the economy? Well, some are going to sustain the productive households. And again, the productive households are the ones that are producing all of the physical goods output for society. And some of the final goods input going into the economy are going to support overhead households. And some of the goods are going to support the productive process itself, right? So rather than supporting the households of the productive workers, you also have to support the factories that they're working at, the manufacturing centers that they're working at, right? The capital goods that are used directly in the productive process itself. And so Mr. LaRouche starts by identifying those factors, breaking those down. And then if we make this one next critical assumption and we say, we want to look at, well, what are all the inputs required for the productive process directly, for the productive households, and for the overhead households? to allow them to reproduce the economy and sustain the economy at the same level, at the same production level, technological level, living standard level. What are the inputs required in order to sustain the economy at the same level it was at, which produced those goods, which became the outputs in that next cycle, right? That's what, in these terms, we would call the energy of the system of the economy. The inputs required to sustain the economy at a certain fixed level of production. Everything left over, everything that's produced in excess of what's required to maintain the economy at that given level of technology it's at currently, is what you call your your net operating profit, or your free energy in Mr. LaRouche's terms. And this allows you to begin to, this is then the key framework then to begin to assess the validity, the significance, the value of one policy versus another policy. Identifying the energy of the system requirements, again, to maintain the economy to the fixed level, to keep it going at whatever fixed level it's at currently, and then whatever free energy is available for reinvestment in expanding the economy in any kind of way, right? Implementing new technologies in the productive sector, in the productive process, expanding, opening up new industries, developing new economic infrastructure platforms, right? Developing new infrastructure systems for new territories in the country, right? If we were to do something like NWAPA, or large-scale weather modification or desalination to address the drought situation in the West, right? Those are places where having the free energy, the ability to have excess steel, excess concrete, excess electronic components, right? Excess whatever, all the excess of the physical good output, physical goods produced by the productive process, being able to utilize those in new ways, that becomes key. So your main question then becomes, from one cycle to the next, do you have a policy that's increasing the free energy available cycle to cycle to cycle, or is that free energy diminishing, right? So if we take a scenario like our doubling electricity production with nuclear power, that's a negentropic program. We're actually utilizing less physical good inputs, again, concrete, steel, cement, etc., into the electricity sector, but being able to generate a higher amount of electricity as a product out of that sector, right? Meaning that some of those physical goods are now available as free energy to be utilized in other parts of the economy, right? That's a negentropic program versus an entropic program, or a collapsing program, or a dying economy like the Green New Deal, in where you have, again, higher inputs required just to try and continue to produce the same level of electricity, right? Like we saw in the previous graph. Green New Deal program, entropic. The LaRouche PAC program, negentropic, real economic growth. These are the kind of programs that are going to allow the economy to get out of this inflationary crisis, rebuild our economy, rebuild our infrastructure, and so on. So to look at this fusion future, we want to look at this fusion future from this standpoint. These higher fusion technologies, these plasma processing technologies, fusion torch technologies, these capabilities to increase the productive powers of labor in the context of understanding the economy as a closed, self-bounded system like that. Well, let's take an example and look at this case of iron and steel production, but look at it in the context of the historical development of the production of iron and steel in the US economy. So if we go back to the 1800s, we take 1880 as a reference point, you can see there was a certain level of productivity for the iron and steel production sector as a whole. On average, they had about 33 tons produced per operative. By 1900, that had over doubled. You're now at 70 tons per operative. By 1960, it got up to 120 tons of iron and steel produced for the iron and steel sector as a whole per operative directly employed in that sector. But what we see here, what we're introducing here critically, is that these increases in productivity that occurred historically, this negentropic process, which we'll see in just a second, were directly tied to new technologies. And those new technologies were characterized by higher energy flux densities of the productive process. So we can see here that the energy flux density of the furnaces that are being used to produce the iron and the steel is going through upward shifts, which are directly related to these higher levels of productivity. Going from furnaces that operate at 6 million BTUs per square meter per hour, right? Just a measure of energy, energy consumed in the furnace per area, per time, going from 6 million BTUs per square meter per hour to 12 million, then to 25 million. So we see this direct relation between increasing the productive powers of the labor force, this productive sector that produces all the physical goods required by society, and the energy flux density employed and utilized in the technology by that productive sector. And as we can see here, we've historically had an increase until we entered, the crazy post-industrial globalization era. We've had an increase in the productivity, we've had an increase in the total iron and steel produced, but it hasn't come at a cost of increasing the amount of people directly employed in that sector of the economy, right? Because they're operating at higher and higher productivities. So again, a negentropic process. The economy can grow, the productivity can grow, meaning that, but still utilizing the same, if not fewer, smaller percentage of your productive operatives to produce these higher levels of output as a function of advancing technology and advancing energy flux density. So this is some historical reference points for the development of the iron and steel sector in the history of the United States. And that really helps to put in context these new technologies that we're talking about connected to a fusion economy. So back to this plasma separation, magnetic separation technology. Here's a quote from one of the articles we cited earlier looking at this. They say, "The technologies are close at hand to overcome this important dependence in a revolutionary way." And in particular here, they were looking at the dependence on importing certain raw materials, certain metals in particular to sustain the economy. That was the focus of this specific article. The article was "Plasma Reactors Will End Reliance on Foreign Minerals." So they say the technologies are close at hand to overcome this import dependence in a revolutionary way. We shall examine the new techniques under development for refining metals, such as the plasma reactor, powered by a plasma torch, using in some designs magnetic processes for the separation of various metals from ores. Not only can these methods produce strategic minerals from low-grade ores, they can also produce enormous increases in productivity and energy efficiency at lower capital costs than conventional methods. So it's a little bit more on these magnetic separation, plasma separation technologies. So if we look back at what we referenced earlier, these proposed designs that can have something on the fold in the domain of a 60-fold increase in productivity in the steelmaking sector. Well, that productivity comes with, again, a leap in the energy flux density of the productive process, right? Just like we saw historically, taking us from the 1800s into the early 1900s into the 1960s. If we look to the future advances in productivity, taking us into the plasma domain far higher levels of productivity, requires that we move into these new domains of higher energy flux density, which is plasmas, high temperature controlled plasma systems. Similar with the aluminum production, this 20-fold increase in productivity outlined in this article for aluminum comes again with a dramatic increase here, almost 4 orders of magnitude increase in the energy flux density of the productive process over current production technologies. And then same with the example we looked at with the the uranium separation for fission fuels. The article goes on to say, the technologies discussed above define the next species of reducing power in intermediate goods production. At the point of application of the plasma torch, they each have roughly an order of magnitude greater energy flux density than existing processes. The future will entail integrating ore separation plants with a fusion plasma source. Beyond that, our task is to mine the moon, the asteroids, and the stars. So that should give you a little bit of a sense of where we should be looking in terms of the opposite of the Green New Deal. Looking at advancing the energy flux density of the economy, looking at advancing the productive capabilities of the economy, reindustrializing, returning to manufacturing and production in the country again. And it all has to be driven by a nuclear fission immediately, and then moving toward a nuclear fusion in the coming generation driver for the economy. So I just want to look at one last sequence to again look at that in a certain historical context. Some people might have seen these charts before, but I find this to be a very useful illustration, again, for real economic progress. So if we look at here, we have a measure of the total energy consumed by the US economy historically, going all the way back from 1776 up through 2020 about. And what we've done is taken the total energy consumed, broken it down by different sources of energy, and then looked at it as a per capita or a per person basis, right? So here we see that wood and biomass from 1776 up to 1850 was the main source of energy for the economy, burning wood, right, and other forms of biomass. And at a per capita level, it sustained a certain level of per person energy consumption throughout the economy. And then we see after 1850, the per capita consumption of wood and biomass falls off. But what came to replace it? We had coal. Coal came in. You had the Industrial Revolution. Coal, again, a higher energy density source of fuel, was able to power a higher energy flux density modes of production and a higher energy flux density of the economy as a totality. So coal comes in, coal then trails off. Then we have petroleum and natural gas coming in, taking the economy to new levels of energy flux density, new levels of productivity, up into the 1960s. And then it begins to fall off. And what we're seeing here, this last step, is the introduction of nuclear fission power. But this is not what happened. This is the forecast for what the economy was going to look like in terms of energy consumption per person under a nuclear program, according to what the John F. Kennedy administration thought. So if you look at what the Kennedy administration was thinking in the early 1960s about the future of the United States, population growth, the continued growth of the US industrial sector, and the development of the US economy and the capabilities of nuclear power, they forecast what looks a very clear continuation of this trend, right? The successive waves of higher energy flux density, higher increases in the energy consumption per person in the economy, powered by higher energy density sources of power. You're moving from wood to coal to oil to gas and to nuclear. And you get this clear, what looks like a clear natural stepwise increase in the advancing energy flux density of the economy. So that's what was supposed to happen. And this is what has actually happened with the globalization policy, with the outsourcing of production, of industry. The United States has stagnated and declined in terms of its energy flux density. And the Green New Deal would make that even worse. I'm just going to jump through these, but this is just some data showing that the major source of the decline is directly attributed to the collapse of the industrial sector. There's no question about it, that the industrial sector is the place where energy consumption collapsed most dramatically over the past generation, 2 generations. So if we're going to save the economy, if we're going to defeating the Green New Deal is necessary. Obviously, I think most people agree with that. Most people understand that. But we have to replace it with a real policy, a real program that's going to work. And it has to be a high energy flux density program, has to be a nuclear program, nuclear fission, nuclear fusion, not just to give us the same electricity we're currently using, but to expand the electricity, to drive the economy, to reindustrialize the economy, to bring back production, and to advance society. And so in terms of this historical evolution, this is our forecast for where we want to go. You know, we've gone through this unfortunate stagnation from, you know, the 1970s up till today, basically. You know, little to no, if not a decline in the energy flux density of the economy as a totality. And so we need to rapidly change that with the large-scale implementation of nuclear fission power. And as you can see there, as we look forward, you know, about a generation down the line, if we currently start investing in fusion technologies, we can see that beginning to make an emergence as the next step for our, you know, children and grandchildren to really pursue and develop. So hopefully that gives people a little bit of a sense of, you know, what we're talking about in terms of a real energy program, a real alternative to the Green New Deal, and what's needed for the economy, and how that affects not just electricity generation, but also production, new production modes, new technologies, and really some exciting frontiers. And what I didn't talk about, but maybe we can get into the Q&A a little bit, you know, the other element of this, which, you know, would be a little bit more extensive to get into, is the connection to space and space exploration for driving forward a lot of these technologies. But I'm just going to leave it there because I think that's plenty to chew on for now.